You might have noticed that in the previous videos, we just had indefinite integrals. We weren't doing definite integrals, though probably most of the ones on your homework are definite integrals, just so that you don't have to type some huge long thing into WebAssign. So what do we do about definite integrals and substitution? You have two options. Your first, and I'll do this integral both ways. Your first option is to change the limits to u-limits. What I mean is, and this is true anytime you do any kind of substitution, not just u-substitution, but anytime when you change the variable, what's going to happen? Look, these limits belong to the original variable, in this case t. If I change the variable, those aren't the right limits anymore. They have to change. So you can change them. And then you don't have to go back to t at the end. You can just use the new limits, the limits on the new variable. So I'll do it first that way. But your second problem, your second thing, is you can just wait, just ignore the limits, change to u, change back to t, and then use the original limits. So change back to t and use original limits. That's your second possibility. I'm going to say this. These two, there's not one that's more work than the other. They're really identical. What I do usually is I change back and use the original limits, not so much because of a problem like this one or two that I'm going to do today. There's only one substitution. But then sometime like later on in the semester, when we get some awful problem and there's like 4 different substitutions, I don't want to go back in and change the limits every time. So for those, I just go all the way back and use the original limits. So it's really up to whatever you want to do. So I'll show you both ways. So this is not a hard problem, right? We saw this very similar to, let's see here. It's very similar. Let me get rid of this. We're going to change the limits. I'll just put that there so we know what we're doing. Very similar. We're going to let u be what's, I'm going to say we're just going to let u be cosine t, right? Because then I'll have u squared in the bottom, and then sine t is just going to be my u, right? So u equals cosine t, du dt is minus sine t. I get a minus, so I get minus du is sine t dt, right? So then, if I put this in here, I'm going to get minus du over u squared for my integrand. Okay? Now what about the limits? The limits belong to t, so I got to substitute the limits into my u equation to find out what my new limits are with respect to u. So when t equals 0, I've got cosine of 0, right? U equals cosine of 0. That's 1. So my lower limit becomes 1. When t equals pi over 6, u equals cosine of pi over 6, which is root 3 over 2. Right? So my top limit is root 3 over 2. Okay? And now, once I do my integral, I just evaluate with these new limits. I don't ever have to go back to t. Okay? So this is clearly u to the minus 1, right? Right? Because that would give you minus 1 to the minus 2. Evaluate from 1 to root 3 over 2. So I'm going to have 2 over root 3 minus 1. So that is what happens when I change the limits. What I should have done. All right, let me get rid of this. I'll leave that. This is my way one. The substitution is going to be the same, so I'm going to put it over here. So way 2, I change back to t. Substitution is the same. I'm just going to make the substitution. What I don't want to do is write those limits there, because then I might forget and I just might evaluate it. So what I usually do is I just leave them off and stick them back in the end. Some people like put X's or something, whatever you want to do. I know I have to evaluate it, so I'm going to put that bar there. I'm not going to write plus C. But then I'm going to put back what u is. U is cosine of t. And now that I'm back into t, I'm going to put the limits that belong to t. So this is just going to be 1 over cosine pi over 6 minus 1 over cosine of 0, which of course gives me the same thing. So this is my method 2. It's no more work. But that's just our different options. All right, I'm going to do another one. One that maybe the u-substitution itself is a little bit more, we have to think about it a little more. I'll change the limits just for kicks. What was that problem? Integral from 0 to 1 of e to the x over 1 plus e to the 2x dx. Okay, so this one, this is another one of those where maybe your first choice might not be the right choice for you, because if I do u equals 1 plus e to the 2x, or u equals e to the 2x, in either way, I'm going to get my du is still with the 2, right? But my one on top only has 1x, only e to the x. So substituting that in there isn't going to work. So this is not a good choice for this one. For what I really want to do for this problem is I actually just want to let u equal e to the x. Because then du dx is also just e to the x. And du is e to the x dx. So I get, okay, we actually saw this before, right? This is just du on the top. This bottom part becomes 1 plus u squared, because you remember what's e to the 2x? It's just e to the x squared. Okay, so recognizing that, and then you can see that pattern. Here's my friend inverse tan again. I tell you that comes up all the time. I told you that, right? So the last thing I want to do is change my limits, where actually we don't want that. We want this one. So when u equals 0, when x equals 0, u equals e to the 0, which is 1. And then when x equal 1, u equal e to the 1, which is just e. Okay, so my limits, my bottom one becomes 1 and my top one becomes e. Okay, so then I just get inverse tan of u evaluated from 1 to e is inverse tan of e minus inverse tan of 1. Okay, and for my purposes, this is fine. I think, so on the test or on the worksheet, we'll just leave it like this. I mean, we know like inverse tan of 1 is pi over 4. You can write that if you want. If you don't, I don't care, because I don't know what inverse tan of e is. Probably, if you're on WebAssign, they want you to put a numerical answer into whatever decimal places they want. So that's fine. But I will always prefer an exact answer. Right. So there's one more thing real quick that I wanted to point out. You know what? I'm just gonna make a separate video, even though it's like a 3-minute thing. But it is a slightly separate topic.